the founder and an educator at Coding and More. Today we are at International Women's Day AI Hackathon. We are doing this in collaboration with Teams in AI. Why are we doing this? It's because as educators, we want to give children like all of you a platform to learn and to use your AI tools in various applications, also for social impact. This time, we are focusing on 3 UN SDGs: quality health, quality education, and gender equality. In order to do these, this competition, we'll be having a series of workshops. Children will be given a chance to work on their AI solutions, and there will be a mentor to guide them working. And to kickstart this event, we are very, very honored to have with us Mr. Sarabjot Singh. Mr. Sarabjot Singh is the founder of Tatras Data. He is also the co-founder and chief data scientist of Sabudh Foundation. And I can see that I have muddled up both of these things up. But I can just tell you one thing from my personal interaction with him, that he's an amazingly kind person. He's my personal go-to person whenever I need any advice. He says he's a self-proclaimed data geek, but he really is. He's been involved in data science since the early 1990s when most of you were not born. Fortunately, I was there, but yeah. He loves, solving for real life problems by developing algorithms. I was also fortunate to sit in, for half an hour of one of his classes at Sabudh, and he's a passionate educator. He's also been an educator at Warwick University. He's currently the director at the Computer Science Engineering at BML University. But you know what, kids? These are all things that people do. But when you truly, truly enjoy what you do and you inspire others to do the same, I think that's what's living life to the fullest, which is why I'm so happy to have Sarabjot Singh here with us so that he can, inspire you with his real life stories. So over to you.
Thank you so much, Supriya. And I hope I do my introduction some justice today. So I shall try and talk today about the joy of being a data scientist and why I enjoy it immensely. The fact that I've been in it for almost 30 years is proof of the fact that it's been a very enjoyable journey for me. What you may have seen in the media recently is the fact that there is a lot of coverage of artificial intelligence. And some of that coverage is talking about how these robots can be dangerous. For example, there was talk about Facebook having to shut down some of its laboratories that were working on these robots that had invented their own language. Or Elon Musk, that most people know today, has talked about how this technology could actually be more dangerous than traditional warfare weapons, right? Yet at the same time, we find that he is investing lots of money in this very technology that he is warning us could destroy the whole of our mankind or humankind for that matter. And then, of course, we have some very interesting things that are happening. For example, this gentleman that we see on the screen right now, he was the world champion of a strategy game called Go. And what he has said when he lost can somebody maybe mute? I think there's somebody who's unmuted. I can hear somebody's voice there.
Aditi, can we mute?
Okay. Great. So, and at the same time, what he said, he lost to AI the year before as well in one of the games. But what he said that in this following year, when he was completely destroyed by AI, he said he couldn't even understand why AI was making the moves it was making. And they were almost like God-like moves. So what is all this confusion that's there in the media? Well, the reason why people are talking about how dangerous AI can be, and it's very important for you young folk to understand the dangers of technology, because there's always a bad side to how you can use technology. And of course, there are wonderful ways in which you can use technology to impact your lives. Well, the bad side of it is the fact that, we can build these kinds of weapons that we are seeing here, which are little drones that this fictitious video was talking about. It's called Slaughter Bots. It's available on YouTube. And the scary thing is that, these drones that we have seen in weddings, taking videos and photographs of and covering joyous occasions like weddings, can be transformed into weapons that can attack human beings, right? And carry small amounts of explosives that can blow a hole through a person's brain and destroy the brain and kill the person, right? And this person here was talking about how by doing face recognition that all of our mobile phones have today, the drone can identify its target and go and destroy that target, right? And he had claimed that at a very low cost, you could get bucket loads or plane loads of these weapons that could go and attack you. At the same time, what is really interesting is the fact that we have other research that's happening where Stanford University is saying it has algorithms that can do better jobs than radiologists in diagnosing problems, right? Medical issues. Similarly, in healthcare, from a heart disease perspective, again, there are these neural networks that are being developed that can do a better job than humans can do today. And why is this exciting? Well, people like you and me who live in big cities are very lucky that if we have any health issues, we have hospitals very close by. But of course, not everybody in the world is that lucky. The majority of our own population of our country lives in areas where healthcare is not available to them. So if we can use machine learning and artificial intelligence to help diagnose the problems, hopefully we can actually get them to travel in time to the hospitals before it becomes too late and help them survive from a heart attack or whatever the disease might be. But of course, this also means our doctors becoming obsolete. Will we need doctors in the future? So all of you who are now starting your journey towards having a career of some sort, some of the careers that we have been looking at traditionally are under threat. They may not exist when you are looking to get jobs. Even if you were looking to work in a retail store selling goods there, well, we have robots now like Pepper that is taking over those jobs, right? And has actually been trialed in the US and in Japan. And if you wanted to be a pizza delivery person, well, think again, because here is a self-driving pizza delivery car that is going to go and deliver Domino's pizzas for you in the future as well. So the world is going to be very exciting and also interesting for all of you. Now, other than the fact that we have all of these interesting applications that we've already talked about, data science and machine learning is about to start changing medicine and science as we understand it. So here is an example where the same folks that developed the artificial intelligence that beat the world champion in Go, a company called DeepMind, have also developed an algorithm that has been able to solve a problem that human scientists haven't been able to solve in the last 50 years. And that's to understand how proteins within our body, how they fold up into these three-dimensional structures. And it is these three-dimensional structures of the proteins that determine what function they do. So if you want to create medicines or vaccines, for example, you need to understand how these proteins fold up into these three-dimensional structures. And artificial intelligence has recently been able to solve this problem to a great extent, and actually was used even in creating the vaccines that we saw come out for COVID. And so, great brains. This is Jeffrey Hinton, who is leading the Google Brain Project and is a very well-respected data scientist, saying, well, if you're thinking of training as a radiologist or as a doctor, you may want to think twice about it. Right? And this is going to come as a big shock to most Indian parents because we all want to make our children doctors, right? But, the reason why this is happening is that we are seeing an exponential growth in technology. You are already involved in learning about artificial intelligence. You may have heard of the Internet of Things. There is, definitely blockchain and robotics that are associated technologies. And now you'll be hearing more and more about quantum computing as well. And because these technologies are growing at such a high speed, you've got to start thinking about what are the skills you need to develop as children that are going to secure your future for you. So it's great that you're learning artificial intelligence, but of course, there are people who are already working on automating the work that data scientists do, right? And so what educators have started thinking about is the fact that you need to develop skills on how you use knowledge, not memorizing knowledge anymore, because you have Google and tools like Google that allow you to search for knowledge. But you need to know how to ask the questions of these tools to really be able to find the right information. You need to be reflective, you have to be inquisitive, you have to be open-minded, you've got to be caring, and these skills are going to be important skills that are going to hold no matter what uncertainty the world brings to you, right? Now, through all of what we've just talked about, it seems like artificial intelligence is a very new subject. But the truth of the matter is that there are people even older than me. Yes, there are people who are even older than me that live in this world that have been thinking about artificial intelligence since the 1950s, right? So this has been in the making for over 70 years almost. And really what these people were driven by was the fact that they had computers that were used in breaking codes in the World War and were being used for large business computations. But these folks were fascinated by these human beings, right? What is it that makes a child, a little child that knows nothing about the world, learn and become cognitively so intelligent and so amazing that they can deal with all the uncertainties that the world throws at them, right? And so what is it that is happening here? And of course, the answer is obvious, right? We all have great sensors. We have eyes, we have ears, we have our tongue, we have our skin, through which we are perceiving our world all the time. So this child sitting in their garden may hear a sound, right? So that's some data that has been picked up by the ears, looks up because the sound is coming from above them and sees an aeroplane. Of course, the child doesn't know what an aeroplane is, but has captured that image using the eyes, right? And so the child points to the aeroplane and goes goo goo gaga, right? Doesn't know what this is, but what he has communicated or she has communicated to the teacher that's sitting next to them or is standing with them, the teacher being an older sibling or a parent, is what is that thing? I don't understand what it is, right? And at that point, the parent or the teacher in general tells them the word, says it's an aeroplane. So now you have a pair of things, right? The child has an image and the child has a sound that has hit its ears again, which is associated with this image. And with this input of an image and the output, which is an aeroplane, the child has an amazing ability to extract features and use those features to discriminate between the aeroplane that it has heard as being the label for this input and everything else that it has experienced prior to that. So what the child is doing on a continuous basis is something that we always tell each other that we should not do, which is to discriminate, right? And discrimination is actually a very important tool where we are learning how things that we are seeing are different from each other, right? Now, interestingly, of course, human beings have limited storage. The brain is an amazing engine, but it has limited power to store information. And I'll give you an example that will make this very clear. So for many years, I lived in Ireland. And in Ireland, there was only one turban walking around, which was mine, right? And so everybody that I knew for many, many years had done feature extraction by looking at me and saying a turban is equal to Sarah. And of course, I thought that, my good looks is what they were thinking about, or all the wonderful things that I spoke about to them. But none of that mattered to them to recognize me. It was all about my turban. So a few years later, my brother came and lived with me and actually worked in the same university. And all of my colleagues who had known me before maybe 5 years by then kept making the mistake of calling him Sarab. And I was, of course, very annoyed, right? Because I thought that I was better looking, taller, more charming than my brother. Of course, everybody believes that. But this fact that these folks that should have known the difference only recognized me as the turban. And so the same happens with the child, right? The next time the child is in the garden and hears a sound and looks up and points at this object flying over them and says, aeroplane, the parents, of course, think this child is never going to succeed in life, right? They have a nervous breakdown as Indian parents thinking, ye to IIT mein nahi ghusega, kind of thing. Why? Because that was a bird, right? And so now they give a chapair, as they do in Punjab, right? Give a thappar to them and say, come on, this is not an aeroplane, this is a bird. What's the child doing then? The child is extracting further features and is recognizing the fact that the object that was flying over them was flapping their wings. And the aeroplane never flapped their wings, for example. And so it develops how to discriminate now and improves on the concept it had learned earlier, which was an aeroplane was anything that flew over their head. And so this is exactly what we are doing in machine learning too, right? We are taking in data from various inputs, we are putting that data together, we are extracting features from that, and then based on those features, we are learning these models. And the wonderful thing is that this is a very repeatable process. And as data scientists, we have a huge variety of data today that didn't exist when I started doing machine learning. When I started doing machine learning, we had data that looked simply like a table, or the time series data that just was one variable that changed over time. But now we have speech, we have images, we have videos, we have these graphs like the internet. And of course, we have a lot of textual data. So how do we combine all of this information? What are the features we extract from these is what excites me and doesn't let me sleep at night. Why? Because we, as data scientists, get to solve complex problems. Right? So for example, in the early days of my company, Tatras, we were trying to look at how can we predict how much power is going to get generated from wind farms. We were looking at how can we use the electrical signals within the brain of human beings to diagnose whether they are suffering from some kind of mental illness. We were building more recently models that can help us in predicting the price of these new currencies called cryptocurrencies and trade them. We were also building chatbots and building platforms for creating chatbots. But the truth of the matter is all of these technologies are driven by the same concept that that little child is executing on day in and day out, which is collect data, extract features, build models, see how the models do, learn from the mistakes you make, and continue to improve on what you're doing. And so, all of these types of problems like adaptive learning, which is another piece which I am very passionate about, where every child is different, learns in different ways. So why is it that we are always trying to teach them the same way? Traditionally in school, we do that only because there is one teacher and maybe 40 children in the class. So the teacher can only teach in one way. But computers and online education can change that. I know you're all frustrated with online education right now because it's been thrust upon you because of COVID, but the future actually lies in our ability to personalize the interaction and the education for everybody, right? We even built a very exciting application for one of our customers where they wanted a mobile phone application. You open the fridge, take a photograph, and the application tries to tell you what you should cook and for your family, right? And this application is out there now being used by people in the US. Now, what is very interesting about this as a data scientist is not just the fact that every morning I have a different problem to solve, right? I'm either trying to solve, how a farmer can get better yield in their crops, or I'm trying to solve a more mundane problem of how a business makes more money. But what has become very interesting recently is this idea of transfer learning. So you build a model in one domain, And then when you go to do the same machine learning in a different domain completely, you can actually take what learning you had from the previous domain and reuse that. Right? So for example, if we think about the ability to discriminate between different objects with our eyes, we are essentially, if we break down the problem, we are looking at different edges that appear in the image. We are constructing with those different geometric shapes and creating an object out of that, right? And then we are deciding, is this object a chair or a table or a monkey, right? It doesn't really matter. Now, the ability to identify those edges is common to all domains. So can we transfer that information and make machine learning easier? That is the question that transfer learning is asking. And here's another story from when I was in England. And I'll come to that story in a second, but there is a problem with transfer learning, right? And the big problem with transfer learning is that most people who are trying to do this transfer of the learning are not deep data scientists. They don't understand the models. They don't understand where the data came from. And one of the things that we in India have to be very cognizant of is the fact that most data from which these models have been created are from Western societies that are industrialized, educated, rich, and democratic. And when we put the 5 words there together, the first letters of them, we get the word weird. So a lot of technology, including artificial intelligence, has been created for the weird users, people who don't live in India, right? And here is where the story gets interesting. So on the right here, I have a chart which is called a growth chart. And when I was in England and I had my first child, we were given a growth chart and were told that as the child grows, the weight of the child must sit somewhere in the middle of these curves, right? For the child to be growing normally. And of course, our daughter was bouncing just about on this last line at the lowest possible point, right? And just about making it, in fact, into this boundary that was created. And so we were very worried because this meant that we were not good parents. The truth of the matter is that these models were built based on Caucasian children or children that were European. And of course, our children are typically smaller, right? And so this is what is referred to as bias within the data. And if we are using models that are biased because the data is specific to a certain region, for example, and we are not recognizing the fact that these models are biased and applying them to solve problems in India, we are going to have a problem, a big, big problem. And here's an example of the kinds of problems we can have, right? So some researchers built a neural network that could discriminate by looking at images of what is a wolf and what is a husky. And it was making only one mistake. So they were very happy with this until they tried to explain why the classification was being made. And what they found was that most of the prediction was based on parts of the image that were not even associated with the animal. It was looking at the background of the image and making these predictions, right? And so it became apparent that firstly, if we have biased data, we can have problems with transferring of models. And secondly, we have issues with the fact that if we don't look deep into the models and don't understand why those predictions are being made, then again, we are going to have issues, right? Especially when we are transferring these models from one domain to another. And there are many such examples, right? So we have self-driving cars today that are doing image recognition to identify what is the road sign that has been created for humans. If we make small changes to that road sign, the algorithm is making a wrong prediction. It's thinking that the speed limit is 45 rather than being a stop sign. And you can just imagine how many accidents would occur if we make these mistakes, right? And so a very, very important thing for all of you great AI experts of the future is to think about, how do I explain the model, right? So whenever we make a prediction, for example, recently we were trying to make a prediction of what's the likelihood of an accident taking place if a bus driver is given a particular bus and made to drive on a particular day, right? And so when we are making these models, we want to understand what are the features that are increasing the probability or reducing the probability of an accident within that domain, right? And this is an area called explainability of models. So explainability is very, very important, and trustworthiness of the models is a very, very important thing that we must think about. And especially as AI folks in India, we should be thinking about how can AI be equitable? How is it going to solve problems that nobody else has solved before for people that have typically not had access to technology? And one of the things that I believe that AI researchers are always doing and data scientists are always doing is to boldly go where no one has gone before, right? So this was a science fiction movie or a television series that I grew up with called Star Trek. As all of you data scientists that are budding right now, you're going to be solving problems that nobody's been able to solve before, right? And we as a generation leave behind for you lots of problems, and we apologize for that in advance. But really, all of these, again, are really only going to be solvable with artificial intelligence and machine learning. So we have left our children, unfortunately, and like I said, apologize for this, looking for high spirits or chardi kala, which is a phrase that we use in Punjabi a great deal, where we feel that we can always solve the problems in the world. We've left our children holding signs on the side of the road saying, where is that high spirit or chardi kala today? And so what I am really excited about is, Supriya, what you're doing with all these children, which is to give them hard problems to solve, right? And we've been working on some of these hard problems also in agriculture, for example, where we are working with farmers in Punjab, looking at ways in which we can help them through technology, using IoT devices or sensors, just like our eyes and ears. These are the eyes and ears of technology, of computers that are sitting in fields and collecting data. We're collecting data with drones, through satellites, and have created an app that allows farmers to understand better and in advance if there's going to be disease in their crops. We are also working with reforestation projects where we are looking at, can we, by listening to birds, there's this little device that we put out into forests and record the sound of birds. And we analyze the sound of birds to understand which birds are coming to which regions of the country. And with that, as the forests grow older, we are looking at how does that change the mix of birds that exist, right? And of course, birds have an impact on many things, including farming. So we are analyzing their speech to understand what these birds are actually, so which birds are populating our forests. And of course, there are researchers we are working with that are even trying to understand what is it that the birds are saying when they're chirping the way they are. We are also working with rural school networks to see how we can solve their problems of power, taking what we had done commercially for European wind farms and applying them to solar energy instead. We are also working on AI for accessibility, where there is a disease called face blindness, where people don't recognize even their mother if they see them in a context that they don't believe they should be in, right? So if they see their mother in their office, they won't recognize the face. And so using smart glasses and AI, the idea here is to be able to tell them, give them clues of who is walking towards them. And my final point, of course, as you're all Star Trekkers and people who are going to be solving the problems of the future, if you haven't seen this movie called The Martian, I would definitely recommend you see it. It's about a NASA scientist who gets left on Mars, and using his capabilities, he finds ways of actually surviving till the next spaceship comes and collects him. right? And you're all going into a very uncertain world where things are going to be changing. The skills that I had pointed to in the beginning, being risk takers, being thinkers, is what is going to solve the problems for you, right? And one of the quotes from this movie was that at some point, everything is going to go south on you. You can either accept that or you can get to work. And I think all of you who have chosen to be part of Coding and More and are learning artificial intelligence and looking at how you can solve the SGD goals as a result of your knowledge are taking the second route, which is definitely a better route, which is to say, let's get to work and solve the problems that the previous generation has left for us. So with that, I'll stop and hand over to you, Supriya. I hope I haven't taken longer than I was expected to. And I hope what I have talked about has made an impact on those of you who have been listening.
That was wonderful. Thank you so much, Sarabjot sir. Can I take 5 minutes of your time to ask if children have questions?
Sure, absolutely.
That was actually really lovely. Kids, would you all like to ask any questions? Don't be shy. There's no such thing as a stupid question.
That's right.
Nothing? No one? Okay.
Can I ask one?
Yes, absolutely.
Yes.
When was like the specific time you started working to be a data scientist?
When did I start working as a data scientist?
Yes.
Well, I was a lot older than you. So I had finished my master's degree. So I was, I guess, around 22 years old and was very lucky to be in the United Kingdom at the time. It was the year 1992. So that's around 30 years ago. And that was a time when machine learning was coming out of the laboratories in university and starting to be applied in industry. And so it was a very exciting time for me to get introduced to this area.
Sir, how do you think AI and quantum computing can go hand in hand?
So, one of the reasons why artificial intelligence has started having the impact that it's having in industry is partly because of the fact that we have got technologies for collecting lots of data. And secondly, it's because we have these wonderful pieces of hardware called GPUs right now, right? Or graphical processing units, and TPUs, which is another kind of brother, a cousin of GPUs, called tensor processing units. And these are able to do very fast computation. And the neural networks and the models that we are building in the real world, are only trainable because we have this very good fast computing hardware available to us. In the 1990s, I know, friends who were doing PhDs in Carnegie Mellon University and so on, who would say to me that I left my neural network training and went for a holiday for a week and came back, right? And it was still running. If we were still using that kind of hardware, we would not have created the advances that we have created today. Now, quantum computing has the promise of taking us to another level in computing power. And so if we get more computing power, the algorithms that we have today, we'll be able to create more complex models or neural networks, right? Because the neural networks today, they are complex, but are nowhere near as complex as the ones we have in our brain. So with quantum computing, I think we would be able to solve bigger problems simply because of the fact we'll have more computing power available to us.
I have a question.
Yes, Vivek.
So, in 1950, did they develop just the theory behind AI that there could be machines which function like this, or did they actually develop a very basic version of artificial intelligence?
They developed a vision for what artificial intelligence should aim to achieve. They developed theory, and actually, as the years progressed, they developed applications also. But those applications were toy applications compared to what we are doing today. right? Whenever you take technology out of the industry, out of the university into industry, it's a very different environment. So in 1990, when that technology came out of the university, while a lot of interesting work had been done in the university, like you said, theoretical work, but also some practical applications of that theoretical work, people started realizing the limitations of what had been developed. And so even though the technology in the 1990s did not become as popular within the industry and didn't have as much impact as it's having today, a lot was learned. So never, and this is a learning for all of us, right? And should be something that you must also remember. Failure is not really a bad thing. When you try and solve a problem and you can't solve it, you have learned a lot. So the worst that can happen once you actually attempt to do something is that you learn a great deal. So you are richer anyway because you have learned a lot, right? So never fear taking the first step, because a lot of the time, I know when I was growing up, I always feared taking the first step on anything because I thought I'll fail. And, there was a stigma associated with it that, oh, this person failed. But that is not to be taken seriously, because actually failure is the best thing that can happen to you earlier in life, because you are learning from that failure, right? So learn, get up, start walking again, fail again, never mind, learn from that, and you will succeed for sure.
Thank you. And I have a second question, which is that what is the thing which you mentioned called the Internet of Things, and how is it connected to AI?
Okay, great question. So, you may have seen things like Alexa or Google Home, right?
Yes.
Where you can talk to them, right? And they will then go and do searches on the internet and provide you with information. So you now have a device in your house that is connected to the internet. There are also fridges that are out there in the market now that you can buy that are connected to the internet. And the application I said, where you open the fridge and take a photograph and decide what you can cook, very soon there's going to be applications embedded in your fridges that are going to say, oh, your milk is finishing. And typically you drink so much milk in a day, or your family drinks so much milk in a day. Should I go and buy milk off Amazon or whatever the online retailer would be, so that the milk comes in time for you to make sure that you always have milk in the house, right? So these are examples of where now everything is getting connected to the internet, right? Even your television is connected to the internet. But if you take it to the other extreme, you also have things like CCTV cameras that are now watching us as we drive, right? Those are also connected to the internet. And we are now analyzing that video footage. And whenever somebody does something naughty, a message goes to them saying you broke a rule. So, you're going to have to pay a fine for it. These are all examples of Internet of Things, where internet was all about computers connected to each other. Now everything, even your toaster, could be connected to the internet in the future, or your coffee machine, where as you drive home, you can switch on your coffee machine using your mobile phone, for example, and have coffee ready for you. Yeah.
Do we have time for one more question, Sarabjot? I know we have said we'll wind up by 7. Can I just take one last question from the kids?
One last question, sure.
Thank you. There's one child had her hand up. So is she there? I think it's Fiona. Fiona, did you have a question, or it's answered now?
I just wanted to ask, how is blockchain connected to AI?
It isn't directly connected to AI. It's a very different kind of application, though. Blockchain is the foundation for cryptocurrencies also, like you may have heard of Bitcoin. And by analyzing the data that is available for us on how the Bitcoin pricing has been behaving in the last while, our trading platform tries to predict the price, right? And that is where AI is getting layered on top of blockchain data, because the data is actually getting stored on the blockchain, right? So they are two different things, but of course, these technologies will work together in the future to create applications, that we are all imagining today.
Thank you so much. Kids, I had promised Sarab sir that we'll wind up by 7. So, I think we should thank him. Not only has he today shared with us the different AI application that he himself has been working on, but he's also shared with you some very important life lessons, right? That you should follow and not worry about doing things because of the fear of failure. So thank you, Sarab sir, for being here with us today, and really appreciate it.
It's a pleasure. Thank you for inviting me. It's been a pleasure to interact with all the children and, of course, all of your folks as well, Supriya. It's an honor to be here. So thank you.
Thank you.
And take care, everyone.
Okay.
Bye.
Thank you.
Thank you.
Bye, sir. Thank you.
Bye.
Thank you, sir.
Bye.
You don't go. Wait.